Open Anthropic's documentation, check the latest VS Code extensions, or scroll through tech feeds on LinkedIn, and you will see 3 letters everywhere: MCP. The sudden rise of this acronym has sparked a specific question for developers. Is learning traditional API development still a priority? Or will this new protocol make those skills obsolete by 2026? The short answer is no. Model Context Protocol, or MCP, is not a replacement for application programming interfaces. In fact, MCP servers rely on standard APIs to perform their internal functions. To understand why one doesn't replace the other, we have to look at what each was specifically engineered to achieve. An API is a communication bridge between 2 static software systems. It is a manual setup requiring a human developer to define every possible interaction in advance. When your phone requests the temperature, it pings a weather API, returning a structured JSON data block. This exchange uses specific HTTP methods: GET to retrieve data, POST to create it, PUT to update, and DELETE to remove, acting as predefined gates for every interaction. This rigid architecture is exactly why APIs became the backbone of modern software. Because everything from authentication tokens to error handling is standardized, developers can read the documentation and integrate new services with a high degree of reliability. Every major application thrives on this developer-dictated predictability. The system only does exactly what it is explicitly told to do, which is the exact constraint that AI agents are beginning to push against. Unlike traditional software, AI models perform reasoning and real-time decision-making. This behavior doesn't always fit into fixed, predefined programming routes. Consider this workflow. You ask an AI to check your calendar, find a free slot, book a meeting, and send a confirmation message. To complete this, the AI must interact with 4 distinct systems: your calendar, time logic, a scheduling tool, and a messaging app. If a developer tries to hard-code this using traditional APIs, the workload is significant. You have to write repetitive boilerplate code to handle the distinct documentation, inputs, and outputs for every single tool in that chain. This creates technical friction. The AI can't naturally discover what an API can do, so you have to map it manually. Because APIs are typically stateless, maintaining context across these 4 steps is difficult, and requiring isolated authentication for every individual tool adds another layer of complexity. Forcing an autonomous AI through these manual integrations creates a bottleneck. It limits the AI's ability to act independently and slows down the speed at which developers can build new features. To address the friction of manual tool mapping, Anthropic introduced the Model Context Protocol. MCP is an AI-native standard designed to organize how models communicate with external data and tools. On the left, a developer has to manually read API documentation to connect a service. On the right, an MCP server automatically broadcasts its available tools and required inputs directly to the AI model in a format it instantly understands. This shifts the decision flow. Instead of the developer dictating the exact sequence of calls in the code, the AI analyzes the list of tools the MCP server has exposed, selects the right one for the current task, and executes it. MCP also handles context and security. While stateless APIs require constant credential passing, MCP maintains the conversational context across multiple steps. It acts as a secure layer, allowing the system to use existing authentication like OAuth on the backend without exposing raw passwords or keys to the AI model itself. MCP shifts the burden of integration away from the developer writing boilerplate and toward the AI making real-time routing decisions. There is a performance trade-off to consider. If you need a system to do one simple single-step task, like fetching a single database row, a direct API call is faster. It goes straight to the server, bypassing the AI reasoning layer entirely. But as the system grows, the math changes. When an AI needs to navigate a web of dozens of different databases, CRMs, and email servers, managing those integrations manually using traditional APIs becomes a maintenance burden. MCP scales more efficiently in these complex environments. It provides a standardized interface that allows the AI to discover and use new tools immediately, without the developer needing to write new custom code for every single addition to the stack. Essentially, you are choosing to prioritize the ability to coordinate complex, multi-system workflows over the raw execution speed of a single connection. APIs are built for direct system communication. MCP is built for intelligent, AI-driven automation. For developers, this means the future isn't about choosing one over the other. Modern enterprise environments will require fluency in both protocols. Core infrastructure, legacy systems, and standard web features will continue to rely on traditional API knowledge. However, building the next generation of AI agent features will require MCP expertise, which is built directly on top of that existing API foundation. The most effective engineers won't choose between these technologies. They will use APIs to build the structural bridge and use MCP to give the AI the map it needs to cross it.